everyone, in this video we are going to play with two different types of models to try to actually help y'all visualize these molecular shapes, or what do these molecules actually look like in a three-dimensional space. So we're going to start off with the simplest form. This is when you have just two atoms. The only way you can connect two atoms is in a linear model. That's the only way. It's with one bond. Two atoms is always going to be linear. Now let's move on to more complicated shapes. Alright, so we're going to start off at the very top here. So we have two atoms on the central atom. So here's my central atom, my white one. These are my two external ones, my green. Okay, no lone pairs. So no matter how I put these together, it is always going to have the linear shape. So this is the ball and stick model. We also have a balloon model, so you can do this at home. So every balloon represents a bond. In the center here where my one hand is, this is my central atom, and then at the very edge on the outside, that's where your external atom is. So right here, my white is in the center and my two green pieces are on the edge. So with the balloon model, we can see when we bring two sets of electron pairs together, it is definitely in a linear shape. So it goes across like this. So two atoms, zero lone pairs, linear. Now let's change it. So we're going to say two atoms, so this stays the same, but now we're going to add a lone pair to it. So I'm going to use my pink balloon to represent a lone pair. So when I add in my pink balloon, we can see that my green balloons start pushing down to the bottom. And so they no longer have that linear geometry. In fact, what they do is they come down and they have that bent geometry. So if I were to show you that in a model, it would look like this one. So we have two atoms here, one atom, here's your central atom, and then this thing that's sticking right out the top, that's your lone pair. So here's your ball and stick model, central atom, two atoms attached to it, one lone pair, definitely a bent geometry. All right, moving on, so we're going to ramp it up a notch. Now we're going to look at two atoms. Okay, here's your central one, two external ones, here's one, here's two, now two lone pairs, so we have to rotate it to see this. Each of these knobs right here are our lone pairs, so here's one, and here's two. Ball and stick model definitely shows that this is a bent geometry. Let's use our balloon models. So two atoms, that's two greens, and then we have two lone pairs. All right, so bear with me here because my hands get a little clunky, and sometimes my ring pops the balloon, so hopefully that doesn't happen here. All right, so we're going to hold in the center. We've got two atoms, that's our green ones here, going down, and then two of our lone pairs at the top. And so if I can hold on and maintain this grip, hopefully we can see that when we put four chunks of electron pairs together, we really are in a competition for space. And so what ends up happening is you get these basically Mickey Mouse ears off the top, and then you have the two green ones that are coming out of the side. So here are your atoms. They are definitely in a bent geometry. They are being forced down to the bottom because these lone pairs are taking up a ton of space. All right, my hand's cramping. That's hard to hold. Okay, moving on. Now we're going to move on to three atoms. Oh, my balloons are going everywhere. Okay, three atoms with zero lone pairs. So we're going to use this model here. So we have 1, 2, and I'm going to add an atom to it. Central atom. Now 1, 2, 3 atoms on the outside, zero lone pairs, no lone pairs. Ignore these white things here, okay? No matter how I hold this is in a trigonal, 3 places, but it's planar. So trigonal planar is what we call this. No matter how I arrange this, it's always going to be flat or in a plane. So now if I brought these together, these would just be 3 of my green balloons. And when I put 3 green balloons together, all we see is they have a planar geometry. They're completely flat across. Nobody's pushing each other up or down. It is planar. So these balloons are a great way to model this if you have a hard time visualizing. All right, we're going to ramp it up. So now we're saying we have 3 green atoms, okay? 3 atoms attached to the central one, and a lone pair. So we're going to add the pink one again. So when I add the pink, hopefully what we can see is that we have the lone pair at the top, and then the 3 ones are being pushed down in an external manner. So the same way we saw before with the bent geometry, we're seeing that here. So all 3 of these are pushed down because the pink lone pair is taking up a lot of space. So in the ball and stick model, what that would look like is we have 1, 2, 3 atoms connected to our central atom, and then here's our spot at the top, 1 lone pair. So when we look at our ball and stick model, we definitely see these 3 things being pushed down, 1 lone pair here. This is called Trigonal Pyramidal, and so you can picture it like this, like a pyramid coming down where the lone pair is taking up the space. All right, one more, stick with me here. So now we're going to say we have 4 atoms. So we have 1, 2, 3, and 4 attached to our central atom. This is called tetrahedral. We say tetra because it has 4 faces. So 1, 2, 3, and then 4 at the bottom. That's where the tetra comes from. But no matter how you hold it, it essentially has 1 coming straight up and then 3 going down at the bottom, no matter how you hold it. All right, this is tetrahedral. So let me see if I can do this and put it together so you can kind of get a visual. But essentially, this would be 4 green balloons coming together. And so where we see the same geometry. So we have 1 at the top and then 3 coming down at the bottom. Okay, this is considered tetrahedral. This is what it would look like in space. Now, I know that was a little clunky. I hope you were able to follow that along. If this was difficult for you, get some balloons. You need 6 balloons, 2 different colors, and you can build them yourself. Also, please use Google. There are so many really cool ways to visualize these molecules, and you can see them in a 3-dimensional space. You can spin them, you can turn them, you can rotate them, and it can help you wrap your mind around the geometry. But you have to know all 6 of these, forward and backwards. Good luck, guys. Take care of yourselves.